Okay, here we've got its cost function. So this is an economics problem. I'm certainly not an expert, but I'll give it a go. The cost in dollars of producing an item, or producing X items in a factory each day, is given by Cx, so the cost as a function of X the number of items, equals 0.00013x cubed plus 0.002x squared. Now these have been, this is a terrible system. This is labour, as in paying your workforce, plus 5x is materials, so whatever they're making in the factory, and this is fixed costs, e.g. taxes, lighting, things like that, water bills, certain licenses, that sort of thing, the things that they have to pay even if they make nothing, and they don't vary with the number of items they make, they're fixed costs. So we have been asked to find C-X, which is called the marginal cost function. So I guess marginal cost function is the rate of change of cost with respect to the number of items you make. So C-X, well, we just need to differ. So power to the front, 3 times the 13 is going to be 39, and nothing's going to carry over, fortunately, because 3 3s are 9, don't carry a digit, 3 1s are 3, so actually I should just be able to have exactly the same amount of decimal points, 1 2 3, and a 3 9 x squared, drop the power by 1, plus, same thing here, power to the front of 2, if I times this number by 2, it's just going to become 0.004x, and then plus 5x turns into 5, and the fixed cost disappear, because this makes sense, because they don't vary with time, so there's no change aspect to them, they are there. Right, so we've got the marginal cost function, looks like that. Then it says find the marginal cost when 150 items are produced, interpret the results. So basically we need to find C-150, so equals 0.00039 times 150 squared plus 0.004 times 150 plus 5, which is around $14.38. So if it was a longer number that you should round for money, by the way, always round to 2 decimal places for money unless you have a very good reason for doing otherwise, e.g. the question tells you to, or because it's only an intermediate result and you're going to use it later. So let me, hang on, that was part A, wasn't it, and that was B. So part C, it says find C151 minus C150, so C151 equals, well it's, dearie me, it's 0.00013 times 151 cubed plus 0.002 times 150 squared plus 5 times 150, it's 151 isn't it, not 150, it'll be 150 in a minute, plus 2200. I'm going to get those numbers in a minute. C150, it's going to be exactly the same, but you change the 151s to 150. 0.00013 times 150 cubed plus 0.002 times 150 squared plus 5 times 150 plus 2200. So that's telling us for part C, C151 should give an answer of 3448.19. C150 should be 3433.75. So C151 minus C151 minus C150, you just subtract these numbers, equals 3448.19 minus 3433.75, and that gives us an answer of $14.44. Right, now I've just realised I forgot to finish part B. I didn't interpret the numbers. So if I just go back to B, we had C-150 was $14.38, I think. And I didn't interpret the results. It's probably now's not a bad time to interpret it. So that's saying after you've made 150 items, this is an estimate because it tells you how the rate of change of cost is per item at the point. So once you've made 150 items, it should cost you $14.38 all in to make the next item. So after 150 items have been made, the cost of making one more item is approximately, I mean it's only a price, we're just using the function 14 and 38, right? So that's telling us at that point the rate of change. Remember, rate of change is about the change in y, in this case c, the cost, per unit 1 in the x direction. So if you've got this graph here and you're on the graph, if you go 1 that way, how much do you have to go up or down by? It's definitely up in this case. So it's saying if I move by 1, this would be 14.38. Right? And then part C, we need to compare the answers. So we knew this number here, so the actual cost of the using the cost function, the cost of the 151st item was 14.44, which is actually pretty close. So B gives a good estimate. It's only actually 6 cents out. So using the marginal cost function for the 151st item, comparing it to the actual cost function, which we're assuming is not an estimate, which it probably is, they only have a 6 cents difference. So actually you can say that for in this particular area, it doesn't mean that the function is reliable everywhere, but around this area of 150, it does give a good estimate of the cost of making the next item.